So I work for Lightbend. I have for the last 6 years almost. Before that, I worked on Scala in academia. Started about in 2007 with higher kind of types and have been paying the price for adding those ever since. You shouldn't laugh that hard. I'm just getting started. So yeah, I lead the team at Lightbend that does the core Scala work, and we're outnumbered by all y'all out there doing magnificent work in open source. So thank you very much for that already. The slides are online. There's a few links here and there. You can find them there. So what keeps us busy right now, obviously, is Scala 2.13. Oops, sorry, it's also the end of the conference for me. Before we get there, though, I just want to plug our developer survey. There's over 2,000 responses in there already, so we're getting on like big data territory, at least as far as I understand that stuff. Please add some more. Please, tweet about it. Encourage your friends and colleagues. We really would like the broadest sample we can possibly get. I know, I'm, talking to somewhat biased people here about, and their opinions about Scala, but we'd really like to hear from you. So there's a Scala Lang post about that with a link to the actual survey, and highly appreciate any advertising you feel comfortable doing about that, or actually taking the survey is great too. The other admin thing to get out of the way is that we're changing to the Apache v2 license. If you have any concerns about that, let us know. You can tell me right now. Oh yeah, you can actually if you want to, just yell during the talk. It's a pretty, as far as I can tell with the lights, we're all friends here. So if you have any concerns, you can yell them out now, or later during the questions, or at the panel, or send us an email. So perhaps you knew already that we alternate library and compiler releases. That's something that we've been doing over the last couple of years to mitigate the upgrade pain, or try to at least only change one core component at a time. So 2.13 is all about the library, and specifically about the collections. M4 that has the new collections in there is out. Go try it. If anything, I have no problem with you going into SBT right now and work on your project. I'll let you know when the interesting bits of the talk are, so you can briefly pay attention. M5 will be the last milestone. We added one because we really wanted to make sure that there's enough time to upgrade the ecosystem and not do that during the RC cycle. That's going really well, so I think we're really tracking very well to get to M5. And then the final would be like September, October timeframe. There's a ticket there where you can track more about this. And the rest of the 2.13 other stuff that we're doing is, in general, trying to make the core library smaller, make the compiler faster. I don't know. People keep asking us about that. There will be some Java 9 support, in the sense that the compiler will run on Java 9, your code will run on Java 9, but we're kind of still playing a bit of a wait and seek with where Java 9 is going, and I'm actually very curious to hear about your thoughts about that later. And as always, we're very keen to improve error messages or anything around your Scala experience that makes it nicer. So the main goal of the collections was basically it had been long enough that we wanted to do another rewrite. Well, just kidding, sorry. I know it's been a long day. It was mostly to deal with a lot of the common gotchas that people have been bitten by over the years with the new collection design, like can build from, and the surprising signatures that requires. And also, it turned out it was slightly over-engineered internally, which made implementation and maintenance pretty hard on the inside. One of the key things we did in 2.12 to make that possible was to improve type inference a little bit with overloaded higher order methods. Turns out that also helps to get Spark to upgrade to 2.12. Well, there are other issues there, but at least one of them is addressed already in 2.12. And like I said, they're available now. The ticket that Seth is coordinating, he's sitting right there in the front row, is number 710 in the community build. Who knows what the community build is? Okay, that's about 100% as well. So we basically have this mono repo in a sense that slurps in, what, is it about 100 something? 170 open source projects, mostly libraries, a few applications, and rewires all their SBT builds together to pretend they're all in a mono repo, and then we test the compiler on that, and we make sure that we don't regress on anybody's compiling their code or running a test suite and so on. So that takes about, what, 8 hours these days to run? 13 hours. Okay, you can tell I'm the manager. I'm behind all the daily stuff, and it's over 1 million lines of code, and so it's a great way to 2 million. Well over 1 million, I said. Would you want to do the talk? Just mic this guy up, please. Anyway, so the community build is something that has really boosted our confidence to make changes like the type inference stuff that I did for higher order methods, and has really rallied the community also in helping us upgrade to the new collections. So Yoshida-san did 18 projects already. I don't know if you can beat that, but you could try. And we'll be very happy to see more people helping out with that upgrade. But like I said, it's actually going pretty well. So thank you very much to everybody. It's not just him, but that's just hard to beat. I mentioned that we're always looking to reduce the footprint of the core library. I mean, as a whole, the Scala ecosystem should come with batteries included. But whatever we want to promise full compatibility for in the standard library, we're trying to make that smaller so that we can eventually get to binary compatible releases of Scala. That means this time that we remove the parallel collections. They're in a separate module. They're not gone, but they're no longer part of the standard library. That also means, funnily enough, that it compiles a little bit faster because the hierarchy got a little simpler. We fit in the Java 9 Compact 1, or actually that started with Java 8, I guess, but where we fit in the Compact 1 profile, which really reduced the footprint of any Scala application that you could use, like the new tools that the Java 9 comes with to generate images of your code. And so that was a drastic reduction in size there. And we'd like to carve out some more modules to open up the ecosystem for stuff like better files to take over Scala I/O, because that's not the best, not the thing that we're most proud of. I mean, a lot of these things historically, and I feel I can say this because I wrote some of that shitty code 10 years ago, shouldn't have survived this long. Yet, that's how it goes. Always working on a faster compiler. I'm not going to go into that, but really proud to see the progress that the team is making there. When it comes to user friendliness, that's a really vague term, but it is really important, even though it was last in my bullet list. Improving tooling is a huge part of that, and the Scala Center has taken the lead there and doing some great work. Everybody is helping with the documentation. It's great to see all those pull requests come in, and it's a great way to start contributing. See Seth's talk for more ideas on if you like to get more involved in creating Scala, and we look forward to seeing you there. One of the example tools that the Scala Center, that's about to go 1.0 is ScalaFix, and that's a great automated refactoring tool for your Scala code base. Who has tried ScalaFix? Yeah, okay, that's a good showing. So we intend to make more use of that as time goes to help you with Scala upgrades. It would be, if you're a library maintainer, for example, you could consider shipping ScalaFix rules to deal with API evolution that you'd like to do. It doesn't just do refactorings, it can also check style, it can do linting. It's one of the things that the compiler does a lot of, but we'd really like to see that get more into a separate tool that can evolve more quickly than the compiler's like 18 to 24-month development cycle. And it's built on Scala Meta, which is of course Eugene Burmako and his team's work. LSB is one of those hip abbreviations or acronyms or whatever. Always mix those up. Things of current times. It stands for Language Server Protocol. It comes from Microsoft, I guess, essentially. And VS Code is what got Martin away from Eclipse, which got him away from Emacs. So that's a pretty interesting trajectory. All this to say that we're actually really excited about this, and that I think this is a really nice path to provide you with really accurate and modern IDE tooling for Scala. The Dotty presentation compiler is, has learned from a lot of the lessons that we learned in Scala 2 and is a lot faster already in that regard. And Tasty and Semantic DB are some of the other things that tie into the story, and we'll talk a little bit more about that later. Once you have one popular acronym, many more follow very quickly. So build server protocol, or the current renaissance of build tools in the Scala ecosystem, which I watch with mixed feelings. I think it's great to have alternatives to SBT. I think there is definitely space for that. But maybe we don't need like 7 new ones. I guess we're not there yet, but please don't insert your new build tool in that last bullet. Collaborate with some of the existing great ones. And of course, there's a lot of the type level stuff that we're really happy to receive in the pull request queue, like literal singleton types that I worked on years ago and spent a lot of time trying to get ready, but just couldn't get around to anymore. And so really happy that that got finished and delivered to the next release. Some really nice improvements that Miles did to implicit search and also type constructor inference, some very nice improvements there too. GitHub will tell you, where we think the highest bang for your buck is in terms of helping us and contributing or starting to contribute. Something that has been on my list, if you've been looking at my archive of presentations, is configurable error reporting. We think it would be really useful to be able to say, I only want deprecation warnings to be fatal. We just never seem to get around to it. So I've done some refactoring to make that easier to do, but we don't really actually have everything in place. So that would be a really cool thing to work on, I think, like fatal warnings or suppress warnings. The nicer REPL is the thing that I currently would really, really like to see. I think there's a lot of scope to steal stuff from Ammonite. And Java has a REPL now, so we need to make sure we kick their asses. Oh wait, is this recorded? I'm in the US, I hope I can't get, yeah. No, I mean, yes, we're one happy family, and I'm not gonna swear again, I swear. But yeah, just some random ideas of what you could do if you wanted to work on something that has a lot of impact and that I think has a nice cycle of seeing like results, like UI design tends to have. And we're really keen to work with the Spark people to help them embed the REPL. That always tends to be a challenge for them. Now that we're either like really I've worn you down already, or that I'm warmed up, or both, I kind of want to reiterate some of the points that Martin made. And believe it or not, these slides are kind of written independently, some of which right before the talk. And I just kind of want to emphasize this point that I think we neglected a little bit over the years, and that Scala is really about the fusion of functional programming and object-oriented programming, and that's really something that I think is at the heart of Scala and at the heart of our community. And that kind of fusion leads to a lot of flexibility, a lot of power, but I think as we've come to realize, it's also really challenging to tell you how to use it well, and for everyone to figure out at any given point in time and every given team size or kind of application that you're working on, which point in the spectrum of Scala you should be right now. And so as you've seen earlier this week, we really see object-oriented programming and functional programming as a whole, not some kind of duality or something like that. And the way I think about this is that objects are basically big functions, and functions are small objects. And maybe my bias towards OO, because I mean, you still have to have a favorite kid, goes towards objects because they subsume, and technically they do. In Scala, a function is just an object, right? But some of the key things that objects have is like mutually recursive references inside an object that a function doesn't have. And I'm going to talk a little bit more about that later. Safety and being concise, they don't have to be at odds. That used to be, and maybe still is, a controversial statement. And it's really about finding, again, the right trade-off between how many types am I going to put in there, how powerful is my type system to get what I want, and ultimately, what do we want from our type system? We want it to keep us from making mistakes that are easy to prevent, right? At the very least. We want it to help us understand our code, maybe not us right now, maybe us in the future, maybe someone else now or in the future. And in order to really make you productive with that, I think type inference is a crucial thing to also have in your language. Because some things are just details. Some things aren't improving your understanding, they're just obscuring it. Or they're liabilities when it comes time to refactor your code. And so using that trade-off tastefully, but at least having access to that trade-off, I think is really helpful, and especially in more functional style code, when you have a lot of combinators working together, it's great that these things are just inferred. I think things like this that tend to get people really excited. Is your code pure? Is it impure? Is it strict or lazy? And it's interesting that pure and lazy are kind of the positive things here, and strict and impure are the bad things. It's really not about should you be in one camp or the other. It's should you be using those tools in your tool belt. Sometimes it's really important to be able to reason about a part of your code, and it really should be pure. Sometimes it's just clear. Sometimes it needs to be fast. Laziness, for example, is not a panacea, and purity certainly isn't either. It can be really hard to understand code that, when you step on one lazy thing that triggers some computation at a distance somewhere. So these are all more or less available to you in Scala, and the interesting challenge here is to figure out how and where to use them. People that will tell you to use only one of them are not telling you the whole story. So this is kind of the summary of all this is like there's a spectrum out there that we offer to you, and I think over the years maybe the spectrum has gotten a little too broad, and it's time to be a little bit more opinionated about this. But there's always going to be a spectrum like this, and that's really what Scala is about. And this is kind of where I was in academia. Like a type checker was considered a lightweight verifier, with really the emphasis on lightweight. Sometimes it's fine to use any. Sometimes it's fine to cast. You have to always be thinking about, in my opinion, the trade-off between how expensive it is this thing fails at runtime, and how expensive is it to actually satisfy the verifier? Like, how hard is it for me to maintain all this type gymnastics? How hard is it going to be for a new person on my team to get into this and to push this code forward, to get whatever needs to be done to get that done? And correctness is great. Don't get me wrong. I'm not against correctness. I got started with Scala by working on its type system, and that's still my favorite part. But use it for really, where you need it. And Kelly did a great talk a while ago about why the free monad isn't free, and think about the cost of the abstractions that you're using, both at runtime and at development time. They do have a cost. And so maybe maybe this can be like a new EDD abbreviation. I think empathy-driven development is something that I want to pitch as like the counterpoint to focusing too much on math. Math is great to see patterns. Math is great to help you in your understanding and reasoning about your code. I'm not saying math is bad. I love math. I spent a lot of time in grad school doing math. But it won't help you come up with good names for your variables. It won't help you come up with like the right structure for your decomposition, for your architecture. It doesn't care about that stuff. That's not what math is about. You need to be able to communicate the intent to yourself and to your team And not just in coding, but in general, it's not about what you want to say. It's about what you hope that the other person is going to understand, right? And I think that's very applicable both to our coding and our community. So I really don't think this is really an opposition. I used maybe the wrong symbol here, but I want to emphasize that when you think about mathematicians and their naming conventions, that's not something that math should really teach you about what to do with programming. There's lots of other things that it can tell you, but that's not one of them. And that's, for example, where things like modules that are really driven by what we need in programming, what we need in design, where we really need mutual recursion, where names matter, where the name of the class and the name of all the fields in the class matter. There's nothing in math that will tell you about that. And if you said everything is a function, you don't get mutual recursion, you don't get thinking about nominal types, you don't get about conveying the intent, neither of the class or the type or the fields of that class or that type. So there's more to it than that. That said, we always want to be doing better with the kind of verification that the Scala type checker will let you do. And as soon as we figure out how to do this pragmatically and in a lightweight way, I'll be super excited to add this to a Scala release. So like I said, to sum this kind of rant up, we will be becoming more opinionated in 3.0, and I think that's really the right thing to do for Scala right now. But the essential flexibility that makes up Scala, that fusion, that will of course never go away. All right, back to the main topic. What's next for us? What are we going to start working on, let's say early next year once 2.13.1 is out? Close the gap to Scala 3 is not a new concern for us. This is something that we've been working on since 2.12, when the trait encoding, the lambda encoding, the way that fields are represented internally have all been aligned with the way that Dottie was doing it back then. And we went back and forth between the two teams on how to really do an efficient trait encoding, for example. In 2.13, the standard libraries were, the standard library changes that we did in 2.13, were also with an eye towards what we want for Scala 3. And so that's a gap, that's a part of the gap that we closed before we get to the 2.14 3.0 jump. And since, if you've been paying attention, this has to be a compiler release, we're going to be focusing on the compiler in 2.14. The big buzzword here is tasty, and there's a lot of interesting things that we can do with that. And from my perspective, migrating our code bases and having to maintain potentially the Dottie compiler and the Scala compiler in the future is pretty scary. So I want to have as little duplicated code between the two as possible. And for 2.14, our goal is to essentially take that zipper that is already they're already joined at the way that they emit bytecode, but we want to pull that all the way as close as possible to the type checker as possible. And that will help also with sharing tooling and providing interop between Scala 2 and 3. So in case you hadn't heard about it yet, tasty, the Y is actually kind of silent. It stands for typed ASTs, which basically just means the Scala program as you type it, and then the type checker runs on it, and that's serialized back to the Scala program that captures all that information. So it's a high-level semantic representation. It's not like some kind of intermediate representation that would be good to emit machine code from. It's really something that tools would be based on. It's like everything you need to know in a pretty sophisticated IDE. I mean, obviously you need more, but it renders the results of type inference, implicit search, overload resolution. All those things are captured in Tasty and erase, in that sense, the biggest difference between Scala 2 and 3. Once we have that typed intermediate representation, the difference between the two are essentially gone. That's the goal. We're not there yet, but Tasty is, an implementation part of Dottie, and we're working now to generalize this. And I should say Guillaume Martès is working on that right now to bring this to 2 and to come up with like a good shared semantic representation between that we can all use. Often when people talk about Tasty, they talk about binary compatibility, and I think for me, there's often two conflated concerns here. One is people want to evolve APIs, and we will always keep evolving APIs, Okay, we might get a little bit more careful and maybe we'll only do like backwards compatible changes. Right now we're like completely, essentially frozen modulo deprecation. That's not what Tasty is about. Tasty is never going to help you change APIs in like a semantic way. Tasty is about removing the distinction between source compatibility concerns and binary compatibility concerns. Java programmers already have the luxury of thinking of binary compatibility basically in terms of source compatibility. If I change something in source, there's a direct translation to bytecode because that's how the platform was conceived. Because Scala C has to do so much magic to compile, fields and traits and super accessors and our different way of doing visibility and all those things, it's very easy to cause binary incompatibilities by making a seemingly innocuous change to your source. With Tasty, that will be gone because we're essentially coming up with our own platform that maps directly to what we think of as like, a semantic representation of your Scala sources. So that's super exciting, obviously. But that's not a silver bullet to finally let you just change APIs at will and not have to worry about it. So I thought it was important to clarify that. So this is going to be a huge task in 2.14, and that will likely mean that 2.14 is going to be more like a longer release cycle, like 24 months or something like that. The other big task that I would really like to do, I mean, not really, that we will do, sorry, I'm not talking to my manager, that we will do is drop a few things. And so the milestone here is, it documents all those if you'd like to reference them later. Early initializers, we talk about them more than we use them probably at this point. They're gone, and we'll have trait parameters instead, which are essentially like the argument list that you can add to a class definition but not to a trait. So that distinction is gone, and that means you don't need early initializers in principle anymore. Procedure syntax, we've also talked about plenty. That's gone. Should have never added that. Complicated existential types will be gone. You can only use wildcards. Value classes will remain there. So these are all things that are deprecated. I think opaque types are a much better way to do it. Wide box macros, I was never a fan. And really excited about the transparent method stuff or whatever it ends up looking like, but something that lets you express your type level computations not in Prolog or not with complicated compiler trickery in your macros, but just in a very intuitive way. Absolutely, you need some form of type level computation. You need some form of deriving, but there have to be better ways to do it than what we have right now. And if all that fails, CodeGen, don't hate on it. It's not that bad. Sometimes you just have to do it that way. But I think we will have most cases covered so that you don't have to do that. Package object inheritance, why get rid of that? Well, there's lots of reasons, but I think my favorite one is that whenever you have a type and you're looking for implicit values of that type, the whole prefix, so all the subpackages in front of that type actually contribute implicits to the implicit scope. I think most people are not aware that that's the case, and it can be really surprising when you define implicits in a package object, or you even worse, you inherit them into the package object. We can't get rid of them entirely. When we do, we would replace them with top-level definitions, but I think that might be too ambitious for 2.14, although I would really like to. Yeah, and like I said, it's kind of coupled to one of the things that we're seeing with implicit scope there that were pretty much unintended consequences of those feature interactions. So what are we adding? I already mentioned trait parameters, opaque types, and type lambdas. I think that's one of those things that we've made painful for you long enough that we should just add direct support for it. For implicits, these are requirements that are essentially coming from Dotty to some extent, but also just from best practices. Do not define implicits without a return type. Okay, like type inference and implicit search are really closely intertwined. When we need to do type inference, while we're deciding whether your implicit definition is a candidate for implicit search, it gets really nasty, and all kinds of hacks are involved that you really don't want to know about. And there's a few things that are driven by the data type generic programming as Miles implemented in Shapeless that will reduce kind of the liability of upgrading to Scala 3, where this is all kind of using pretty Scala 2 specific hacks that we're bringing into the language so that there's a good upgrade path for these really essential things to Scala 3. And this is getting like on the really maybe we would like to, but probably not list. I mean, there is already some support for var handles and barriers because, well, boring reasons of Java 9's verifier getting stricter. But some stuff like minimal value types or value types for value classes, if we can add support or leverage what they're going to add, that would be really exciting. But we're kind of taking a wait and see approach there. So I guess we're about halfway. No, I'm just kidding. We're almost done. I guess you can see the progress bar here. Anyway, so Scala 3, you already know all about it. My take on it is that it's basically kind of like a 2.15, just a little bit more exciting. And I hope you're a lot more excited. I am, but what I mean by this is that your upgrade hopefully won't be exciting in a bad way, or at least not more so than a regular 2.14, 2.15 upgrade. And that's really what our roadmap has been about since 2.12, and is really accelerating with 2.14. So for me, in kind of descending order, I think implicit function types in Scala 3 are really cool. Union types have lots of applications and stuff that I honestly don't see much in my daily programming, but I can definitely see in the talks at the conference that there's some really interesting use cases for them. Transparent methods and just principled meta programming, they go hand in hand, and I think that's really exciting. Transparent, by the way, is what used to be called inline in Dotty, but I think transparent and opaque are a really nice symmetry that really convey what they are for. New macros, I'm excited because they'll be based on tasty and no longer on all the nitty-gritty details of the compiler, so that we don't have to worry about breaking your macros while we're working on the compiler internals. Enum, because, well, we had to finally add that, and static for Java interop reasons. So thank you very much for sticking with me through the end here at the conference. I hope you had a good time. Thank you so much to all our contributors, community for being here, Scala Center for all the great work they're doing, and the Dotty team for all the the productive collaboration we have with them. Happy to take questions now, or you might want to run out and grab a drink or something, and we can talk at the panel as you wish. Thanks again. There is a microphone set up right there if you had a question right now, or grab me at some point between now and the panel.
I have a question.
There you go.
Yeah. Will mutual tail recursion optimization be something in Scala 3?
Mutual tail recursion in Scala 3. It's not, I mean, no, it's not really on the roadmap. I'm kind of caught out of the blue on that one.
It's a pretty specific question, I know.
Yeah, no, but it's yeah, you got me thinking. I have to think a little bit about where we are on that right now, or what the challenges would be with implementing that. But yeah, let's chat offline about that. Yeah, but I'm not aware of any current efforts on that. Yeah.
So, from my understanding, opaque types definitely not going to 2.13. Is that right?
Well, usually what we do is we do the implementation in the release before the one that we are going to support it officially, but then it'll be available under a flag. So it's actually pretty challenging to implement in Scala 2. Scala 3 has a nicer architecture for dealing with context-sensitive, taking context into account when you're doing subtyping, and we don't, which is also why GADT type checking, for example, is not great in Scala 2. Anyway, as a shorter answer, I really hope it'll be available under like Xsource 2.14 in like 2.13 n+1, and then officially in 2.14. The SIP is essentially accepted pending implementation. And if you'd like to help with the implementation or with providing more motivating use cases or tests or whatever it is, yeah, let's chat.
Sure. Actually, another interesting question is that there's some interest of introducing some,
Can you talk a little bit closer to the mic?
Sure.
I can't hear.
There is actually some interest in bringing some functional programming type classes like monoids or
type classes.
Into either a standard library or module. So what's your take on that?
So the question is, how do we feel about integrating more type? Like, do you mean like actual type classes like applicative and functor into the standard library, or support for type classes, like defining type classes more directly in the language?
Well, the second, the latter is the prerequisite of the first, but
okay.
I mean,
I think it would be useful. I think it's not clear yet, how we should do this. I don't know if you saw the pull request where Martin, like basically parked his current thinking on that, and then people got really worried or excited or both about, basically what was a draft for one way we think we could do it. So I think it's clear that there's a lot of contention around this issue in the community, and we really need to figure out how we can get everybody to agree on that design. And I think that's going to be challenging, but obviously worth doing. When it comes to bringing those core concepts into the standard library, I think that actually might be harder still. Well, maybe it'll get easier once we actually agree on how to do type classes in Scala. Really honestly with you, we have so much to do that type classes are not like the number, like in the top 3 of my to-do list right now. But I am very curious to see what we can do, and I'm very open to discussing how we could do it in a way that works for both the type level community and the Scala Z community.
Thank you.
Thank you. Thanks for the questions. All right, looks like no one is queuing up at the mic. Well, I'm sure you'll have more in time for the panel. Thanks again. See you in a bit.